a quantity that relates to things. Anyone know what they relate? Mass, good. Not kinetic energy. It's very similar to kinetic energy, but it relates mass. So if something has a great mass, it has a large momentum. And if something has a large velocity, it also has a great momentum. Okay, so we're going to relate both mass and velocity. It relates to both, all right? And the equation is very straightforward. I mean, conceptually, if something has a larger mass, what would happen to its momentum? Would increase, right? So momentum would be the product of the mass. And then if something's going faster, what would be true about its momentum? It would also increase, yeah. So momentum is simply mass times velocity. Okay? The symbol we use for momentum is a lowercase p. So we could write this equation as p equals mv. Momentum equals mass times velocity. Okay? It's very similar to inertia. Inertia, though, is directly proportional to what quantity? Mass, right? The larger the mass, the greater the inertia, the harder it is to resist its change. And that's true with momentum as well, conceptually especially. But it also has to do with velocity. So the faster you're moving, the harder it would be to stop the object as well, right, if it's moving faster. The units for this, there's no fancy units, it's just the base units. So mass, what's the units for mass? And the units for velocity? Meters per second. Okay? Kilogram meters per second. All right, so let's just do a simple calculation here, simple problem we'll talk about conceptually. Let's do the age-old problem of truck versus fly. Okay, so let's take our truck. Let's say it has a mass of 4,000 kilograms. He's cruising along at 30. It's about 65 miles an hour, 30 meters per second. Okay, we have fly. He has a mass, I don't know, say, let's make it a big fly, 2 grams. It's like a horsefly, a dragonfly. Okay, so here's a question. How fast is a fly traveling if it has the same momentum as the truck?
Oh my God, that's like heck of fast.
So if we want the fly and the truck basically to stop when they come together, how fast do we want our fly? So go ahead and calculate it. I'll give you a few minutes to do this. It's not a hard calculation. Superfly. There you go. So let's find P truck first. P truck would be 400 kilograms times 30 meters per second, right? So what's the momentum of the truck? 120,000. Okay, if we want the fly to have the same momentum, Well, what's going to have to be true about its speed? It's going to have to be fast, right? If we want to have the same momentum as a truck, we're going to need a fast fly. So how do we find it? Well, we'll just set it equal. So don't forget that the mass needs to be in what? Kilograms. So you always do have to convert that. So that's going to be 2.002 kilograms times the v fly. So divide your 120 by your 0.002, and how fast is our fly? 60 million. Okay, that sounds good. So 60 times 10 to the 6 meters per second, or 60 megameters per second. That's pretty fast. Just to give you some context, the speed of light is 300 times 10 to the 6. 300 million. So our fly is moving pretty close to the speed of light if we want to have the same. Okay, so why does it have to go so fast? Because its mass is so small. Now it is possible for the fly to easily have a greater speed than the car. Sorry, a greater momentum than the car. What would have to be true about the car or the truck? Yeah, what if the truck was stopped? If the truck was stopped, what's the momentum of the truck? 0. Okay, easy for the fly to surpass the momentum of the truck in that case. Okay? All right, so